Alright, in this video, we're going to learn how to troubleshoot one of the most common causes of failures of why the SQL Server Relational Engine won't start. And that failure often has to do with permissions. So the first thing we're going to do is come down and open up our users. Alright, computer management. Let's go to local users and groups. Let's choose users, and all I did here was create a user, very vanilla user. Let's click on them. Mike Test, member of users. Right. There's really nothing to this guy, it's just a very simple user. Alright, so once I had him created, I went to SQL Server Configuration Manager and opened that, and I came here, just double clicked on that, and I said I want the engine to start to log on with that account. There it is, Mike Test. However, I do not have a domain, and oftentimes it is done via the domain. So let's take a look at that. So let's say the domain is ISE, and let's say the account is let's say the box is SQL Server 01. So a lot of organizations may do this. Service account, SRV, SQL 01. And I can't type. And this is the account within this domain, right, that we would use to start the engine. Now, some companies will use the same account for all their SQL Server boxes. They'll have one for the engine. Maybe they say SQL Server 01, and they will call this the engine. And then they'll have one for the agent, and this is what they'll use throughout the organization on other boxes. Again, they might not use SQL Server 01. They might just give it SQL account. That's not such a good idea, and I'm going to show you why. I like the idea of having a domain account for each of your production servers. Now, that's going to require some work on the admin side, but that's okay. The network administrator guys will get over it. Now, I'm going to show you why it's a bad idea to use this account for all your boxes in the organization. So let's go kill that. Nope, I don't want to save. Let's go open up the command prompt, and let's net stop MSSQL server. Yep, that is fine. So we've just stopped that account. Now what I've seen happen, and I've seen this happen more than once. Let's go take a look at that. I should have kept this open. So let's open up our users. Let's navigate to our users again. So we want to go to local groups, we want to go to users, and we want to go to this test that's running the SQL Server agent, and we want to disable. Now what happens is maybe a Windows administrator isn't familiar, maybe he's new and he's not familiar with this account, so he's doing cleanup and he goes behind and he locks this out. And now let's try to start SQL Server. And that's what we get. All right. The service won't start, and it's kind of a generic error, but it gives us enough to know that something is wrong with the account that SQL Server is starting under. All right, let's pull this over here. So when we see this error message, right, service enough start due to login failure, we know that it's most likely, there's a very high probability that it's this account, and we need to go check that account out. And we know, because we just disabled it, that it was disabled. And I've actually seen that more than once. I've seen it possibly 3 or 4 times in my career, where it's done accidentally. It's done maybe because the password expires normally and the account gets locked. I mean, there are different ways that it can happen. However, the end result isn't good for our SQL service here. Now, remember we spoke about just a few minutes ago why it would be bad to have one account. So what if this was the only account that we were using throughout the enterprise? You just brought down every SQL Server in the organization. That's a bad day, let me tell you. And again, I've seen that happen. Bad day. So I like the practice of the SQL Server server service with one account on each box and the SQL Server agent with one account on each box. All right, so let's go back and fix our problem. We want to enable the account. Let's apply it. Let's come back and let's restart it. And just like that, we've started our SQL Server agent. See, after we refreshed it, we can see that the account is up and running with this account. All right, let's take a look at another failure message I've seen on occasion. So we're going to open up our command prompt. We want to find the ports that are in use. So we want to hit a net stat dash O, and this lists the ports that are in use. So let's take 49211. All right, we want to come to, oh, it's already open, SQL Server Configuration Manager. I was going to come down here and open it. SQL Server Configuration Manager. We want to navigate to SQL Server Network Configuration, Protocols for Microsoft SQL Server. We want to click on TCP/IP. We want to come down to Address, and we want to change the port. The default port is 1433, and as a security practice, many DBAs want to change this port, but they rarely look at the ports that are already established before they do that. And this is what happens when they don't. All right, now that we've changed the default port from 1433 to one that's already in use, let's start the SQL Server service and see what we get. So we're going to net start. A service-specific error occurred, and that's about as helpful as nothing. That gives us no information. All right, so when we get a message that's as useless as this, the first thing we want to do is navigate to the SQL Server error logs. So let's do that. And they are located here. So let's come over here and click, and you can see they're under Program Files, Microsoft SQL Server, the name of the instance here, MSQL, logs, and we've got some garbage here. Let's go down and find the error log. It's the first one, and let's open it. And let's open it with Notepad. And let's come down to the bottom, and let's open this up a little bit. And we can see the reason. There it is, the reason. We're looking for reason. Unable to initialize the TCP/IP listener. Well, why? All right. Only one usage of each socket address is normally permitted. So what that's saying is you can use one port. So change the port to one that's not already in use. All right. So let's change that back to its normal 1433. Or, you know what? Let's change it to 4928. Let's say OK. OK. Now let's try to start it. And just like that, the SQL Server engine is up and running. There we go. Let's go see what the port's running under. Bingo. All right. All right, so it's a good idea to check what ports are in use before you go changing them on the server. All right, in this lesson, we're going to learn how to start with the clean error log. Now, we've already done this once before, but it doesn't hurt to do it again, especially because in this section, we're going to comb the error logs one by one. So we want it as clean as possible. So the first thing we're going to do is open SQL Server Configuration Manager, and you should already have that in the taskbar. We want to stop our instance, and again, we're going to work with the Express edition. And you can see it's called 2K14 Express. That's what the EXPR stands for. We're going to right click. We're going to stop it. All right, now we want to navigate to the location of the error logs for our instance, which is right here. Right. We'll go for the logs. And now we want to single click, hold down the Shift key, click again, right click, delete. And now they're gone. And we will see that they will be recreated upon startup. So let's go ahead and start our instance. And there they are. Now let's open our error logs. And this will be a clean error log. And we know it's a clean error log because we've deleted them and started from 0. So let's right click on the error log, open with, and our handy notepad, and there it is. A clean error log from a SQL Server 2014 Express Edition. In this lesson, we're going to learn what's in the error log. The error log is a treasure trove of information in an outage situation. And we need to learn the defaults so we can more easily spot the anomalies. Alright, let's break down this error log from a 2014 Standard Edition instance. This represents the error log when SQL Server was initially started. The first line gives us the build of SQL Server and the date of that build. The next line gives us the copyright, and the one after that, the SKU and the build number. Now the SKU is kind of a little outdated. The SKU is what would show up on a package if you still received disks in package form. The next one gives us the time SQL Server was restarted and more copyright information. The following line gives us the process ID. This is obtained when the getProcessID API is called. It's the same one you'll see in Task Manager. The next line gives us the hardware that SQL Server was installed on top of. In my example, you can see I've installed it on an Optiplex 3020. The next line gives us the authentication mode. And in our example, you can see I've chosen the mix mode. The next line gives us the location for the error log for the instance. And the next one after that gives us the service account SQL Server was started under. In 2005, Microsoft started to print the startup options as read from the registry. And this can be really useful if a problem occurs due to invalid startup parameters. And these are our last lines in this segment. In this lesson, we're going to continue to learn about the SQL Server error log. So the first line we see gives us information about the processor. This is the total CPU supported by Windows. It also gives us a number of logical processors SQL Server can use based upon your license. Threads are scheduled to run based on their scheduling priority. The priority levels are from 0, the lowest priority, to 31, the highest priority. Only the 0-page thread can have a priority of 0. The 0-page thread is a system thread responsible for zeroing any free pages when there are no other threads to be run. So this line is telling us the thread priority for SQL Server. At this juncture, although it's not shown in the error log, the SQL OS is initialized. You can more accurately see where the SQL OS is initialized by enabling lightweight pooling or enabling fiber mode. Next, we see the total physical memory available on the server and the correlation used on this instance. The next line shows us the previous process ID for the instance and the date and time it was shut down. The next line provides us with NUMA-related information. The next line is the lock allocation information. When the server is started with lock set to 0, the lock manager allocates 2% of the memory allocated to SQL Server to an initial pool of lock structures. As the pool of locks is exhausted, additional locks are allocated. The dynamic lock pool does not allocate more than 40% of the memory allocated to SQL Server. Not seen, but at this juncture the SQL Server network interface is initialized. Now this doesn't mean the code is executed to listen to network connections. It means routines like WSA startup for WinSock are called to prepare the server to listen for those connections. The next line tells us the number of DAC connections there are for this instance. DAC is the Dedicated Administrator Console. The next line tells us the system databases are starting. At this point, processing gets forked. We can see in the error log the master has started. The master database is always recovered first, as it contains pointers to all the other system databases. Notice the SPID that starts the master. In our example, it's SPID 7. Now, on the very last line of the pick, you'll see SQL Server starts other system databases using different SPIDs. Next, transactions that were in flight were rolled back, and any log transactions that were committed but not written to the database file were rolled forward. A checkpoint happens and CLR is loaded. In the next line, we can see auditing has started. Auditing an instance of SQL Server Database Engine or individual database involves tracking and logging events that occurred on the database engine. Next, we can see the default trace is started, and on the following line, we can see the name of the instance is printed. Lastly, we can see that the MSD database is started, and this is where the split occurs. We can see that because the SPID that starts the MSD database is different from the SPID that has been used at this juncture. In this lesson, we're going to continue to learn about the SQL Server error log. Essentially, the MS SQL system resource is a DLL that the SQL Server development team wrote. All static stored procedures and internal procedures that users can or shouldn't modify are stored in this database. Next, we can see the databases on the instance are started. Next, we can see a certificate was successfully loaded for encryption. Now, what's this mean? Now, this certificate refers to a self-generated certificate used as a best effort mechanism to protect the SQL Server login information, including passwords, when using SQL authentication. By default, this self-signed certificate should only affect the login information and only when using SQL Server authentication. There's no penalty for using Windows authentication. Now be aware that because this is a self-generated certificate, it is subject to an active attack, but it provides better defense against passive attackers sniffing passwords than previous SQL Server versions did. Next, we can see the port SQL Server is listening on. And we can see that it's listening on the same port for IPv6 and for IPv4. These protocols provide IP addresses, the phone numbers for the internet that are responsible for identifying computers and devices so they can communicate with one another. Next, we can see the resource database build version. This can help if we have a corrupt resource DB and we need to swap it out with the same version. Next, we can see SQL Server is ready to accept connections. SQL Server can listen for connection requests via multiple listeners, such as TCP/IP, shared memory, or named pipes. Next, we can see the transactions are either rolled forward or rolled backwards for MSDB. On the following line, we can see the port number that's used for the DAC. On the next line, we can see that SQL Server is ready for work. It's ready to accept connections. The next two lines provide us with information about the SPNs. SPNs are used by the Kerberos authentication protocol. So it's beyond the scope of this lesson, but there are known issues with SPNs, and sometimes when we have SPN issues, we have to take steps to correct those issues. And this is where you can find the SP information for the instance you may need to troubleshoot. Finally, on the last section, we can see the model database is started. So this is an error log from an Express edition. And the first thing you may notice, although you may not because it is hidden, is that the dedicated administrator connection is not enabled. Why? Because it's disabled on this edition. Alright, let's move down to the last block of logs. So we're starting up the model database. Alright, we're clearing tempdb. Notice there it says clearing tempdb. Remember, there's a myth that's perpetuated even by Microsoft that the tempdb database is rebuilt or recreated every time SQL Server starts, and that's not true. And you can see specifically it says we're clearing TempDB. It doesn't say we're recreating TempDB. All right, so in the next line we see starting up the database TempDB. Now notice if you'll see the SPIDs that have been running at this point, we're on SPID 12. Now we jump to a different SPID when we report that the service broker endpoint is disabled. And then at the very bottom, when recovery is complete, we jump to another SPID. Alright, so service broker endpoint is disabled. Okay, that's just saying that the server broker is stopped at this point. Database mirroring endpoint is disabled or stopped. The same principle. Mirroring is stopped. The endpoint is stopped. Alright, service broker manager has started. And finally, recovery is complete. Now, again, because this is an Express edition, we're going to see things a little differently in the different editions. Alright, that concludes our look at the error log. We've gone over line by line what's in the error log, and at this point we're better prepared to pick out anomalies because we know what the error log looks like when it's initially started.